Hello everyone, today I'll tell you about the rarest among the so-called rare earth metals, thulium. However absurd it may sound, the rarest among the rare. And yes, with the city of Tula this metal is not connected in any way, unless the Tula gingerbread actually contains lanthanides. Nonetheless, in the periodic table of chemical elements, thulium is indeed featured in the row of those lanthanides, under the number 69. Thulium is very difficult to obtain, as only one part of this metal can be found in 100 trillion pieces of the Earth's crust. Even the famous scientist Charles James needed to go through about 15,000 purification steps in order to get a more or less pure thulium bromide from an ore, the role of which can be taken by gadolinite, or for example monazite. Many of you may have noticed that in almost all of the videos about lanthanides I mention all the same minerals, and it's not just a coincidence. The fact is that often in such minerals one can find a whole gallery of lanthanide compounds that often accompany each other in natural sources and show the same chemical properties due to the similar structure of the electron shell. So it is not that easy to separate them from each other. By the way, approximately 80% of all lanthanide deposits are located in China, as is the production of compounds from these elements. But let's return to thulium. From the outside, this element looks like a shiny metal, resistant to oxidation in air. This piece of thulium was made back in year 1990, and since that time it almost did not oxidize. Because of its rarity, thulium now has a fairly high price. For 10 grams you may pay about $100. What's also interesting is the structure of this thulium sample, consisting of the so-called metal dendrites, obtained by sublimation of a metal in vacuum. According to its chemical properties, thulium hardly differs from other lanthanides. This metal also dissolves well in hydrochloric acid, where it forms thulium chloride, a substance with a slightly greenish tinge. The same unusual green color can be seen in the sparks of burning thulium in air, which is quite unusual, since the sparks of other lanthanides are usually white. When the metal thulium burns in air, an oxide of this metal is formed. Nowadays, thulium compounds are added to phosphors, which allows them to glow in the ultraviolet and blue color. This property is used for the protection of euro banknotes from counterfeit. Thulium compounds are added to the ink for the notes, which under the ultraviolet light makes those particles glow in blue. The common properties of thulium with the other lanthanide metals can be seen from the behavior of thulium chloride in the presence of vanadase or tungstase. When the solution of these substances come into contact, the insoluble precipitates of thulium compounds form. On the application, the non-radioactive isotope of thulium-169 finds its place in the manufacture of lasers used in surgery. For example, a solid-state laser using aluminum yttrium garnet with thulium impurities is used to treat prostatitis and remove tumors. Though a more interesting application finds the radioactive isotope thulium-170 that emits a soft gamma rays. It is used in the production of compact sources of X-ray radiation, which are used for obtaining dental images and in searching for microcracks in mechanical and electronic devices. The miniature thulium devices are suitable for X-ray diagnostics in the tissues and organs that are difficult and sometimes impossible to scan with the conventional X-ray machines. The only drawback of such devices is that the isotope thulium-170 is quite expensive and has a half-life of about 170 days, meaning devices using this isotope are short-lived. In conclusion, due to its rarity and high price, thulium is currently not so widespread in application as the other lanthanides, but in the end it can be said that this metal is quite unique, the rarest among the rare. For the provided thulium for the experiments, I'll thank the company onyxmed.com. I'll put a link to their site in the video description. Now you know a little bit more about one of the other metals. If you would like to support the continuous production of science videos like this one, please support channel on Patreon, link in the video description. Please like this video and subscribe to my channel to see many more new and interesting